Hello friends, column. Column are the vertical member which are subjected with the axial compressive load. Now we have the two different sort of column, the long column and the short column. If the column is very short, means the diameter should very high, very large. If the diameter is very large, then it is going to be applied with the load, then it is going to be filled by the means of crushing. But if the long column we are going to consider, at that case the column is going to be show some deflection, and that deflection is known as buckling. If you show this diagram, in this diagram we are using a 1/4, the fourth is your P. When the load is applied, that is load is your compressive in nature, then what happened, we have given a small dotted line here, that is shown the deflection of the beam, and that deflection is known as your buckling. Now what happened, in order to find out the desired equations, we have taken a one section at the distance of x from the top. At that time the deflection, or we can say eccentricity from this original beam, is your taken as the y, means the x is your somewhere the vertical distance and y is your horizontal distance. So if someone asks about what do you mean by here the moment is your force into distance, my dear friend, force is your P and the distance traveled by its perpendicular is your y, and it's going in the opposite direction. That's the reason the mx, moment about any section x, should be equal to your P into y in the minus form. So we have already mentioned here P into y. Now we all know about the energy equation. The energy equation is your EI d square y dx square equal to mx. We have already known of the mx. If we are going to put the value of mx here, dear, we have got it EI d square y dx square equal to minus P into y. Now this is some equation which is come under the category of differential equation, and now we have to go for it. On solving the differential equation, we will get an equation or solution y is equal to C1 cos within a bracket under root of P upon EI x plus C2 sine within a bracket P upon EI into x. Now we have the two challenge right now, C1 and C2. Without knowing this, we are not able to be moved further. So we are going with the AND condition. If you are focusing on this diagram, the AND condition, we have the two AND condition we are going to be right now. If the value of x is 0, means the x is not there, at that case this portion y should be always equal to 0. And if we are going for, if x is your total to L, equal to L, here again the y is equal to 0. If I name it A and B, at the A x is 0, y is 0, at B if x is L, y is also equal to 0. So I have mentioned here two boundary conditions. Boundary condition number 1, x is 0, y is 0. If I am putting it in this equation, 0 should be equal to C1 cos 0 is always 1 plus C2 sin 0 is equal to 0, means C1 is somewhere giving the value of 0. Moving on the second boundary condition, that is your x is equal to L and y is equal to 0, means again it should be equal to 0. C1 is already 0, C2 into sine under root of P upon EI into L. Now we have come in this conclusion. This is our conclusion. I have marked it with another color. I am coming in this conclusion. So dear, it is not possible that C2 should be got for equal to 0. So somewhere it's having some value, somewhere these quantities should be equal to 0. I have already mentioned here C2 should not be equal to 0, means the sine under root of P upon EI L should be equal to 0, and if it is equal to 0, we know that when the sine value is going to become the 0, it is equal to 0 when there is a pi, n pi. So we have make it solve under root of P upon EI should be equal to L in equal to n pi. Now if someone asks about the P is that critical load, that load which make that desired effect. So my dear friend, if on squaring P upon EI L square n square upon into pi square. So if we make it solitary, n square pi square EI upon L square. Now here we have got a one term n square. If you know about the whirling of the shaft, in there is a number of loop is coming, and generally we are working on the loop which should be equal to 1. So that's the reason n value should be always termed as 1. That is, n is your number of buckling loop, P is your Euler critical load. So on putting the value, the desired equation should be your P should be equal to pi square EI upon L square. And my dear friend, this is your Euler load, or we can also say it like a crippling load. That's all from this. Thank you very much. Stay tuned for the further video. Thank you.